Hey everyone, today I will show you how to sketch and identify the surface of a given equation. In this case, I will use the equation x equals y squared plus 4z squared as my example. So the way we're going to do this is by using traces. Basically, we're going to set each variable equal to 0 in a plane. So to start, to go into our xy plane, we will set our z coordinate, or z value, equal to 0. This will produce the equation x equals y squared. Then we already know from this equation that the shape is going to be a parabola on the xy plane. And if we plug in a value for x, say we make x equal to 4, and we get the equation y squared equals 4, we know that the boundaries of this parabola will be y equals plus minus 2. So the equation will, the shape of this equation on the xy plane, so y-axis, x-axis, will look somewhat like this. So since the x is a positive sign, we know that the parabola is showing in the right direction, and the boundaries are 2 and negative 2. So the parabola will look something like this. I apologize for the subpar drawing performance. But now we know what the shape looks like on the xy plane. We have to repeat the same process in the xz plane and in the yz plane. And this will look something like this. So for the yz plane, we have to set x equal to 0. This will give us the equation 0 equals y squared plus 4z squared. And then after rearranging, we get y squared equals minus 4z squared. We cannot have a negative coefficient in front of the z value, since this would give us an equation in the, since this would give us a square in the imaginary numbers, which is not something that we want to do right now. So in this case, the only way in which this is plausible is when both the y coordinate, not the y coordinate, is when the y coefficient, is when the y value and the z value are both 0. I'm sorry. So when the y value and the z value are both 0, we know that this equation corresponds to the origin in the yz plane. So we know that this is the origin of our shape. Then to finalize, we need to find the trace in the xz plane. Whoops. This is done in similar fashion. First, we need to set our set our y equal to 0. This produces the equation x equals 4z squared. Then we can substitute the value for x, which would give us 4 equals 4z squared, which can be reduced to 1 equals z squared, which is equal to z equals plus minus 1. So from this, we can see that we get a parabola, x equals 4z squared. That is the equation for a shape of a parabola in the second dimension. And we can sketch this with the boundaries 1 and minus 1. So that would look something like, sorry, let me just delete this. That would look something like this. So we would have our z-axis and our x-axis, and similarly to the first one, it would just be a right side parabola like this. So now that we have our three graphs given the traces that we have produced, we can go on to draw the final image. The final shape. So if we have our z-axis, our y-axis, and then our x-axis, we know that on the xy plane, so on this lower plane, we have our boundaries at 2 and minus 2, and we have a parabola looking like this. Then we know that on the YZ axis, it's just the origin. And then on the ZX axis, we have our point -1 and our point 1, and we know that the shape of the parabola just goes through it like this, and then we can draw our three-dimensional shape. So I know the drawing isn't exactly pristine, but we can still deduct that this equation right here is a elliptical paraboloid shape. Thank you very much for listening. Have a great day.